Hello, I'm Jacob from the City Roads Public Library, and you're watching Adventures in Science, where I will attempt and explain various scientific experiments with varying degrees of success. Because if there's one thing you need to know about science, is that sometimes it's more art than science. Today we're going to be making something called an electromagnet. Electromagnets are a lot like regular magnets, except while regular or permanent magnets constantly produce a magnetic field, electromagnets don't. Electromagnets exist in lots of everyday objects, such as computers, motors, and even VCRs. Wait, people still use VCRs, right? No? Fine. Moving on. Electromagnets are generally made by taking a length of conductive wire, usually copper, and wrapping it in loops that, when activated by electricity, create a magnetic field. This electromagnetic coil is more commonly known as a solenoid. However, there is one more super important thing required in order to create an electromagnet, and that is something known as a core. This core is usually made out of iron, but the core can be made of any metal that is what is called ferromagnetic, which is a fancy Latin word for something that just really wants to create a magnetic field. This ferromagnetic core is important because it naturally wants to strengthen and amplify our electromagnets. And while iron and its carbon-enhanced cousin steel may be among the most common, materials like cobalt, nickel, and even neodymium are also frequently used. This brings us to our experiment. While we know that a core, coil, and electricity can create an electromagnet, do additional coil loops around our ferromagnetic core create a stronger magnetic reaction? Using 4 different amounts of coiled loops, 50, 100, 150, and finally 200, we will gauge how well each electromagnet does by seeing how many metal paper clips it can pick up when connected to our battery. But first, let's watch me count all 500 loops. I'm just kidding. So first we have our 50 looped core, which, after connecting it to our battery, is a decent magnet, collecting 8, 11, 11, 6, and 10 paper clips, bringing our average to around 9.2. Next we have our 100 looped core, which gives us 20, 17, 22, 19, and 18, giving the 100 loop an average of 19.2, well over twice what 50 loops gave us. Now we have our 150 loops, which nets us 21, 22, 19, 19 again, and 17 paper clips, giving us an average of 19.6. Finally, we have our 200 looped core, which acts a lot like the last 2 parts of our experiment, giving us 17, 21, 19, 18, and 20. This leads us to a conveniently average number of 19. Looking at all of our data, we can clearly see the massive jump between 50 and 100 coiled loops, and from there it seems to just sort of hit a plateau, suggesting something is limiting our electromagnet. It could be the limited current coming out of our battery. It could be that the bolts we use just aren't effective cores, as the ones I purchased were made of galvanized steel rather than untreated iron. Unfortunately, as I am unwilling to connect our electromagnets to my car battery, and finding a simple iron bolt is way harder than I expected it to be, I'm going to have to leave the better science up to you. Seriously, don't connect anything to your car battery. It's in your car for a reason, just leave it.